Hi guys, welcome back to my channel, and guys, in today's video we're going to be learning about LCM and GCF. As you can see on my screen, I have wrote down what does LCM mean, least common multiple, and GCF, greatest common factor. So in my last video, I did prime factorization. So from my past 2-3 videos, this is related to that, so I want you guys to go and watch those videos. So let's get started with an LCM example. Okay, let me give you I'm gonna be using the same question for both LCM GCF because that's a bit related so you guys understand a bit better. And let's start with a question 18 and 45. Okay, well, I'm gonna be writing down 18 and 45. Okay, let's just start out with 18. Let's do the prime factorization. So first step is doing the prime factorization, which I showed how to do in my last video. So go check that out so it helps you. What two numbers do you multiply together to get 18? 9 and 2. So I'm going to write 9 and 2 here. Times. Is 2 a prime number or 9 a prime number? I know that 2 is, so I'm going to circle that down. Is 9 a prime number? No, it's not. What times what? Okay, my bad. What times what equals to 9? 3 times 3 equals to 9. Is 3 a prime number? Yes, it is. I'm going to circle both numbers down. Now I don't have any numbers left to multiply. Since all these both numbers were prime numbers, I'm going to be writing them down. Okay. I'm going to be writing a sentence down at the bottom. 18 equals to 2 times 3. This is very important to write, okay? So you would want to do this. My other number was 45. Let's get back to 45. 45. What times what equals to 45? 9 and 5. I'm going to be writing 9 and 5. Is 5 or 9 a prime number? I know that 5 is a prime number, so I'm going to circle it down. Is 9 a prime number? No, it's not. What two numbers you multiply together to get 9? 3 and 3. Is 3 and 3 a prime number? Yes, they both are prime numbers. I'm going to circle them down, and there's no number left, so I'm going to leave. Okay, now I need to write my statement. 45 equals to 3 times 3 times 5. Now remember, we're doing LCM. I'm going to write this down in big numbers. Actually, I'm going to write this down in blue just because I wrote LCM in blue. LCM. We're doing LCM right now, okay? Don't forget, okay? Because you're going to get confused or else. Okay, now, when I've got my numbers, by numbers I mean like this and this, my statement, I'm gonna need to compare. So I'm gonna see in both the numbers there are 3's. Which number has more 3's? They both have 2 3's, so I'm gonna just write out 3 equals to twice. Okay, now in this number there's a 2, but in this number there's not a 2. So I'm gonna compare which number has more 2's. In 18 there are more 2's and there's only one 2, so I'm going to write ones. Now 5, there's only one 5 in this number, so I'm going to write 5 ones, and since other number there's no 5, that's why I'm only writing ones anyways. Okay, now for like what I just said about the twice ones, this number is a bad example to show like the twice and ones, but that's fine, okay? Okay, now since I said we all know that what are twices are 1/3, right? So by twice, I mean like 2 3's. So now I'm going to write LCM equals to 3 times 3. Why I put 2 3's? Because I said twice. And I'm going to put 1, 2, since I said 1, 2 once, and 5 also once, and I said 5 once. Okay, now I'm going to multiply and get my answer. 3 times 3, 9. 9 times 2, 18. 18 times 5, I think that's 90. Right, guys? Yeah, that's 90. 90 is our LCM. Okay, there we go. We got our LCM. Let's move on to GCF. Now GCF is a bit easier in my opinion. I don't know about you guys, but let's try GCM out. I'm gonna write not GCM, GCF, greatest common factor. Okay, I'm going to be using the same question. Okay, the same question. So we're gonna start out with the same way, prime factorization. 18 and 45. I'm gonna do prime factorization again. 18, 9 and 2. I'm doing the same thing, guys, again. Okay? Since I have the same numbers. But you always, in both these things, you have to use prime factorization. That's why I started out with prime factorization first. Okay, I'm gonna use my other number as 45, since that's what I chose to do. 5 and 9. 5, 3 and 3, circle, circle. Now I've got my I did my prime factorization. This time I'm gonna write it out. GCF, greatest common factor. GCF equals to 18 equals to 2 times 3 times 3. 45 equals to 3 times 3 times 5. Okay. Now, what you do in greatest common factor is a bit different. You don't write twice and once, and that's why I think it's a bit easier. What you do instead is, I'm going to compare these numbers again. Now, there is 1, 2 in this number, but there's no 2's in 45. So I'm going to cross that out. I don't need that. There's 1, 3 in 18 and 1, 3 in 45. So I'm going to use a different color and underline it because I need it, right? Now, there's another 3 in 18 and there's another 3 in 45. I need that since in both numbers there's a 3. There's a 5 in 45, but there's no 5 in 18. So I don't need that. I'm going to cross that out. So now I'm going to look at my underlined numbers. My underlined numbers were, I'm going to write this. GCF equals to 3 times 3. I'm not going to write this 4 times. Okay? I'm not going to write this 4 times. I'm not going to write 3 4 times. Since I'm going to compare. Now, there's a comparison in both. Okay? If, let's say, I'm just going to write out 2 3's. Okay? I'm not going to write out 4 because we need to multiply only one side. Okay? So 3 times 3 equals 2. 3 times 3 equals to 9. So my GCF is 9. There we go. We got our answer. There we go, guys. Thanks for watching. Subscribe, like, and yeah, bye-bye.